Hello and welcome to Unit 1, Lesson 2 on line. I expect you to take notes like you would in class, make all the text marking that I make, and add things in that you see. So it should go well. Tonight, or this afternoon, or this morning, whenever you're watching it, we're going to cover these 4 objectives, and basically we're going to learn how to substitute variables into lines. So let's go ahead. So let's just start with a mathematical model. You'll get the hang of it as we try. You got to try a few of these to get the hang of it. You should know how to do this, though. You've covered it in math classes and other classes. So a mathematical model essentially is an equation that involves the independent and dependent variables. Lines on the graph and area underneath the line may describe an equation, hence the mathematical model or an equation. Okay, so here's some data taken from somebody that's pitching versus the distance a ball travels off the bat. Okay, now the question is, can it be fit by a linear line? Well, I'll show you how to use log or pro over the next few days, but let's go ahead and try it out. It actually has a linear fit function, and sure enough, that looks pretty good. It doesn't hit all the lines, but when you curve like it does like this, it's hard, to get that. You can't fit that much better than that. So we'll stick with that linear line, and we'll discuss that later on this unit, how to deal with curvy lines, but that's not where we're at right now. So that fits pretty well. So let's go here. Okay, so mathematically that line can be described by the equation y is equal to mx plus b right there. There's that right there, right over there, okay? Where y is the dependent variable, and it can be replaced by the name of the variable that is graphed on the y-axis. X is the name that's graphed on the x-axis, and I talked about that in a previous lesson, but I'm going to show you how to do that in just a bit. M represents the slope and is calculated by taking the change in y over the change in x, or the dependent divided by the independent variables. The slope is the ratio of change between the two variables. In this case, we're going to use the log or pro value, though on the worksheet you're going to have to create your own. The quick version of slope is rise divided by run, or if it's negative, it's fall divided by run, and it becomes a negative number. The more technical version of this is y2 minus y1 divided by x2 minus x1. So anyway, you can use any of those equations to find slope. I'm not going to demonstrate slope. I can for you in class tomorrow if you don't know how to do that. Now the y-intercept, or the b part of the y is equal to mx plus b equation, is the y-intercept, and it's written as a unit of measurement. Mathematically, it's the value of y when x equals 0. So the biggest mistakes when people are doing these is they don't sub the appropriate names in, they don't actually name independent or dependent variables, and they don't include units. It's a habit you got to get out of, and math, generally they don't have you do that. Now we're going to apply the math to come up with the equations. It's the crux of what we do here in physics. Okay, so you'll get the hang of this here. All right, so now we got to just go ahead and substitute in the variables. So we start with our equation, y equals mx plus b. Okay, so let's first find the y. Okay, where we go to find that. So y is the distance traveled. Let me show you how I found that. So you go back to the graph. Here it is. Here's my distance traveled right there. And I just call it dt, so I don't have to write out distance traveled. So notice when I substitute this in, I do not include this unit. Okay, and that's going to be tricky for most of you to get. Okay, now we come back here and we look for the slope, and again, log or pro gives us that. So I'll show you where it gives it that. Here's my slope right there. Notice it's 4.466 feet mile per hour. That's a mouthful, and I'm going to go ahead and simplify that unit. I want you to simplify the units, so you're going to have to use your algebra. So what you do when you go to simplify these, you look at what's on the y. That's a feet. That's a miles per hour. Okay, so remember, slope is rise over run. Okay, so on the next slide I'm going to do that. So the rise, the part that goes up on the y-axis, is feet. Okay, the run is miles per hour. All right, now we got to simplify that. Now, if you don't remember how to do that in math, it's pretty simple. Think about, I always like to use numbers to help my proofs. So let's say you have $2 bills and you have 4 quarters. Well, how many quarters go in that $2 bill? How much change would you get? Well, you get 8. 8 quarters goes in that. Okay. Now, what you did to get that is you took 2 times the reciprocal of the bottom, and that gets you 8. All right. Now we're going to do that same thing here for this one right here. All right, so we got feet divided by, all right, or times hours over miles. So you end up with a unit of, which is a little strange, it'll make sense in the end, of hours per miles. Okay, so when we come back over here, you get feet, hours per mile, and I rounded that off. I'll teach you how to do significant figures later. I'm not going to focus on them right now. There's a lot of other things I'd rather have you get. Okay, x, part of this, part of the x, part of the equation, we get from the name on the x-axis. Okay, so the name, notice I'm not doing the unit here, speed of pitch. So I went ahead and just called it SOP, or speed of pitch. Okay, and then the y-intercept, again, 152 feet. Now where I got that from is from Logger Pro. Now you'll have to manually find that on, I think, worksheet 2 before we do the tutorials. So don't be confused by that. Again, you've done that in math before, and then the y-intercept, of course, is right here, 152 feet. Notice I keep the units on that one. Okay, so when I put it all together, all right, I get a equation. Let me change my pen color here. Distance traveled is equal to my slope, 4.47 feet hours per miles, okay, multiplied by my x, SOP, notice no units, and then plus my 152 feet. Okay, so notice it takes a jump here. So we have, I'm going to highlight these. I always do this. So we have no units here. Yes units here. See that? Yes. No. And then yes units. That's, I kind of call it my skip method. It's a little mnemonic for memory, because I know students a lot of times have trouble. When should they put units? When should they not? Again, I'm going to be very technical about how I grade these. So we go no, yes, no, yes. All right, so that's how I remember to do that. Now we can actually use that. So when I ask you with a mathematical relationship, okay, state in words, just given the general mathematical relationship is appropriate in this case, and so in this case, the distance traveled is proportional to the speed of the pitch. Okay, and then this statement is just a mathematical thing. Proportional means that it's a linear type relationship. Okay, and we'll go from there. So now let's go ahead and try to apply. Okay, and then let's talk about the meaning of the slope and y-intercept. All right, so slope, again, they all, in math, it's just, rise over run, or a mathematical thing. It actually means something in reality, and so the slope is the ratio of change between the distance the ball travels and the speed of the pitch right there. Now, you can do that generically for any time I ask you what the slope means. All you have to do is say it's the ratio of change between, and then you substitute in the value here. It would be your y value versus your x value right there. So here's your y versus x, just to kind of help simplify it. All right, now the y-intercept, okay, by definition is mathematically the value of y when x equals 0. Let me go back a few slides. All right, it is just simply where, there we go, just simply here, it's where this line crosses over the y-axis, okay? And that's a value, actually it's right here, I'm sorry, here's 0, okay? There's 0, so it crosses over here. And it's the value of the distance traveled, which is 152, when speed of pitch is equal to 0, down here. And so anytime you're trying to find the y-intercept, it's just as simple as that. It's the value of whatever the name is for the y when whatever the name is the value for x right there. You just plug that in. And of course I put a unit in there. And it does make sense. It could be when he's hitting off a tee or something like that. It could represent air. Anyway, so let's go ahead and apply this equation to a problem. And again, we got that nice equation we did. So it says, how far will Pujols hit a 31-mile-an-hour pitch? So all we have to do for this is take our equation, 4.47, okay, feet, hours per miles, times our x value, which in this case we're going to call it 31 miles per hour, 31 miles per hour, all right, plus the 152 feet. All right, and so notice here, we go ahead and do that. We calculate that out, and we get I'm going to continue it over down there. A distance traveled equal to 291 feet. Now let's look at our units. I always make sure units work out. So we got hour cancels, mile cancels, mile cancels. So we're left with feet plus feet. And so that works out like that. So 291 feet. So we can actually check that on the graph to see if that makes sense in reality. And so here's 50 right down here. And so that'd be 10, 20, 30. So 31 is somewhere approximately in here. Yeah, that's pretty close. That's what the equation is. It gives you where, it's an estimate for where you think he would hit it. It's a pretty good estimate as well. All right, do the same thing for the second part. You can try that out. And the answer for the 96-mile-an-hour pitch is 581 feet, which, again, that may or may not be reasonable. We're kind of getting to the edge of where this graph is accurate. Because if you notice here at 90, here's 90 down here. You come up, and you're getting, this part of your graph is not quite as accurate as the beginning part of the graph. So, again, we would probably asterisk that data from there. All right, I think I'm done with this set of slides. Okay. Now, again, come with class tomorrow with questions on that section. Now, there's going to be a part 2. Don't forget to watch part 2 of this video. It's also assigned to you as homework.